Right, good afternoon everyone. Welcome to the Multicluster Special Interest Group introduction. I'm Quinton Hoole. I am the SIG lead for Multicluster, and my colleague Irfan and I will be giving you a brief introduction to the work that we've been doing, what the SIG is all about, hopefully encourage you to contribute and engage with the SIG, and answer any questions that you might have along the way. All right, with no further ado, looks like we've got a couple of people rolling in late from lunch here. We'll get started. So this is roughly what we're going to talk to you about. You know, what do we see the mission of this particular special interest group to be? What is the current work we're doing? As many of you might be familiar, in Kubernetes, we have this concept of a SIG, a special interest group, and inside the SIG, we typically have one or more projects, sub-projects. And these sometimes are, relatively unrelated to each other than the general area of the SIG, and sometimes they're much more closely related. So we'll talk about what we're doing, and we'll also encourage you to, if there are other projects or if you have projects that are kind of floating around outside there somewhere that are closely related to multi-cluster work, we'd like to encourage you to, come and talk to us about them, collaborate, etc. And we're going to go into some detail on a couple of them, Federation in particular, what we call Federation version 2. Irfan's going to take you through some of the concepts there. The level of detail is not going to be very deep today. That's what tomorrow's session is for. We have a deep dive session where we're going to go into much more detail there, demonstrate the APIs and how it all works. So just so you're clear on what we're going to be doing today. If anybody wants to interrupt us along the way, we're quite happy with that. There will be a Q&A section at the end, but sometimes it's easier. We've got a nice small group here, so if you do have a specific question related to the topic we're talking about, I don't mind if you interrupt me. So let's start with a little bit of history about where multi-cluster SIG came from, what kinds of problems we're trying to solve, etc. So some of you may remember as far back as essentially the beginning of Kubernetes. I was at the time working at Google, and I had a history at Google of running big systems, in particular the advertising systems at Google. And we had many clusters. I don't have pictures. I used to have some nice slides showing how many clusters Google and Amazon these days as well also have around the world. And most of the applications in these big companies run in all of these data centers. And I was, one of the people responsible for managing all of these things, and we ended up building a lot of tooling on top of Borg at the time, which was the internal container management system used at Google, to make all the stuff work properly. And so because we didn't have that in Kubernetes at the time, Kubernetes was a single cluster thing, I kicked off a project which became known as Federation, Cluster Federation, and there was a nickname given called Kubernetes at the time, which some of you might remember. So that's the history behind where this came from. We then broadened our scope. I guess that was 18 months ago, 2 years ago, something like that. There was this realization that there are actually many different ways to solve some of these problems, and we didn't want to be too prescriptive about you need to use cluster federation to solve any multi-cluster problem. And so we renamed the SIG and broadened the charter slightly to make it clear that if you're using Spinnaker to replicate stuff across clusters, or if you have GitHub repos where you check something in and it gets pulled into a lot of clusters, this is all fundamentally trying to solve similar problems, which is how do you manage large numbers of clusters in the same way that Kubernetes manages large numbers of nodes. So some of you remember in the days before Kubernetes, you would kind of log into each node and run containers or virtual machines or whatever, and we solved that problem. But as soon as you have even 5 or 10 or 15 clusters, and we have people using Cluster Federation who have thousands of clusters, the problem starts to look quite similar. But there are some fundamental differences that need to be solved. So that's a little bit of anecdotal background to what we're doing here. So this is all common challenges related to the management of multiple clusters, and not only the clusters themselves, obviously, but the applications that live inside them. So it's not uncommon to have an application that spans across multiple regions or multiple continents even, And then how do you make these applications work? How do you replicate data? How do you do load balancing between clusters? How do you make sure that the configuration of your application is consistent across the clusters? All of these things. How do you upgrade your software in such a way that you don't bring all the clusters down at the same time? So these are problems that are near and dear to our heart, and that's what we like to spend our time thinking about and building software to solve. So what do the APIs look like? We started off in the early days with sort of a first attempt, which was to take the Kubernetes API and say, what happens if we took exactly that API and we just said, instead of having one Kubernetes cluster that you send this thing to, we have software that makes sure that that Kubernetes specification goes to all the clusters in a consistent and sensible way. We very quickly realized, and we kind of anticipated this, that the API itself of Kubernetes was never designed to handle multiple clusters. So we ended up saying, oh, okay, what happens if I have a daemon set or a replica set or a deployment, and I want to have 2/3 of it go to this cluster and 1/3 of it go to another cluster? There's no way in the API to express that. So we knew that was a problem, but we thought we'd at least prove out the concept, and we used, at the time, annotations. So we annotated the existing Kubernetes API objects with this kind of information, and we got fairly far down the line proving out the idea. And then around about 2 years ago, 18 months ago, we redesigned the whole API so that multi-cluster is a first-class concept in the API. So it has a lot of similarities with Kubernetes, but it is actually more specifically designed for multi-cluster applications. And yeah, so another interesting part of the SIG is that we're not only about end-to-end solutions. Federation is maybe an example of you can run this thing and you can manage multiple clusters using it. But we also quite like the idea of building standalone useful things that can be used in other contexts as well. So there are good examples in the sub-projects. We have a cluster registry. So there are many cases that don't necessarily involve federation, where you need to have a list of clusters that exist, and you need to be able to log into them all and do various things with them. So that's a standalone project that we have, and it's used in a variety of different contexts. And there are command line tools that are useful for when you have lots of clusters to manage, all of these kinds of things. Any questions so far? Makes sense? I'm seeing some nods in the audience, so hopefully this stuff makes sense. So I've alluded to some of our sub-projects. I think we've spoken about Federation v2 at the moment. It sort of provides 2 tiers of support at the moment. So we found that there were use cases where all that somebody wanted to do was take a configuration, whether it's a cluster configuration or an application configuration, and just replicate it as is across a bunch of clusters. It must be exactly the same, don't do anything fancy, and we built a set of components and a subsystem that can do that for you. But then we also found that there were, once you get into slightly more sophisticated situations, you often need software that can automatically decide, for example, where these things should go. Maybe you don't want to deploy to all your clusters, but only a subset of them. Maybe your company has a policy that says that test workloads go into clusters A, B, and C, but production workloads go into D, E, and F. And you don't want to have your application administrators making these decisions because based on experience that, for example, I had at Google, these clusters change all the time. At one point in time, you might have 35 of them, and we're tearing down 3 of them this month, and we're bringing up another 6 next month, and you don't want to have to reconfigure all your applications every time this happens. So you want software to do that automatically for you. So we provide these higher level features as well. In terms of the roadmap for this functionality, we have an alpha version out today. We're using it not in production yet. What we're trying to do is prove out the APIs and stabilize the implementation. We plan to have that beta in the very near future. I would like to say 2018. That might be a little optimistic, but certainly not long after the end of this year. And then we would encourage people to use it and get it into GA early next year. And we have quite a few companies collaborating, making that happen. As I mentioned, we have the cluster registry. This is conceptually a fairly simple thing. you want to be able to list a bunch of clusters. You want to make sure that everyone knows where they are, what the API endpoints are, what they're called. You want to be able to label them, perhaps. You want to be able to find all the clusters that are labeled for production or for testing or for tenant A or tenant B. Any of these applications are valid applications for the cluster registry. We have an implementation at the moment. It is deployed as a custom resource definition, a CRD, in a normal Kubernetes cluster, and you can use it. And in fact, we use this internally in Federation to keep track of our clusters. And then we have a project that was mostly initiated by Google, actually, multi-cluster Ingress. So one of the common problems that a lot of people face is what happens if you have an application that spans multiple clusters and you want to do load balancing across these clusters. So some of you will be familiar with the Ingress load balancer abstraction in Kubernetes. So how do you make that thing work across multiple clusters? And so we have an implementation of that. It currently works only on Google Cloud, but it is extensible to other public and private clouds. If anyone's interested in extending it, that would be very well received. And something else I've kind of briefly touched on, but I want to make it very clear that you may not be interested in cluster federation, you may not be interested in the cluster registry, but we've come across a lot of organizations, and I haven't actually cleared with any of them whether I can mention their names here, so I will withhold them, but I'm aware of at least 4 companies or 5 companies that are doing production stuff with large numbers of clusters. Some of them started with Federation v1 and then morphed that into whatever they needed. Others, started with other approaches. And many of them are trying to solve the same problems. And one of the functions of the special interest groups in Kubernetes, at least in Kubernetes, is to provide a sort of a neutral home for these discussions to happen. We don't all need to be solving the same problem, 5 times over in slightly different ways. There's a general interest in trying to standardize some of this stuff and share experiences. So that's something we really strongly encourage. And we have collaboration work going on with various companies doing this kind of stuff. This is just a list of a few active contributors at the moment in SIG Multicluster, and most of them are actively involved. In fact, all of those on the list are actively involved in the Federation project. As I mentioned, Google is also involved in the Kubemci, Multicluster Ingress, and the cluster registry. And we would strongly encourage any of your companies who have an interest in running, more than one cluster to come and talk to us about what your ideas are. And at this point, I'm going to hand over to my colleague Irfan, who's going to dive a little deeper into some of the sub-projects, in particular Federation.
Thank you, Quinton. Hello. Am I audible with this? Seems audible. Switched on? It's on, yes. Yeah, it seems to. Yeah, so Quinton talked about the 3 projects that we have been working on actively, say, in last 1 year. Federation V2 effort is the most, I would say, well received, or the most, seeing most active contribution. And the folks listed in the previous slide were actually all of the companies which are contributing to Federation V2. So as Quinton also mentioned, Kubemci and Cluster Registry is something that Google folks did a while ago. So what is Federation V2? How many of you actually knew about Federation or the V1 effort? I mean, can I see a raise of hands? Okay. So Federation V1 was something where we tried to reuse the K8s API, the same K8s API, the way it is exactly, and fit it into the Federation control plane. And the resources created over there, we tried to make an intelligent guess how to distribute that resource into the subclusters. That didn't work out very well for us because there was a hell lot of information that was needed to specify details about what cluster, what labels, where it has to go, and so forth and so much. So what we had to do was we had to define a set of metadata which is specific to the Federation control plane and that wraps around the K8s resource or K8s API. That is how the Federation V2 API or that's how it looks like as of now. So by definition, if you see, it's a common interface or a common layer which we want to put forth as a surface to the multiplicity of K8s clusters. And we started off with a separate API server. So when we initiated this project, we started off with API Server Builder. If you folks know, there is a project called API Server Builder which can bootstrap your APIs and install that as a standalone API server which can be aggregated with the K8s API server. But now we have moved on to the CRD based resources, so that need also is gone. Aggregating an API server has its own challenges. You have to deal with authorization yourself, and there are a couple of other things. In case of CRD based approach, you can use all the stuff that is available with the given API server. So any Kubernetes cluster you have, everything is managed and maintained. You just need to install this API on top of that. How we do it is we have a layered approach. So we say we have the primitives or the building blocks where you can define the resources, the template which this federated API should wrap. So for example, a federated secret is wrapped by for example, a Kubernetes secret is wrapped by a federated secret. Then additional two resources are you have to define a placement and an override. A placement is in which clusters this particular resource goes, and an override is per cluster what are the fields you want to change or be different or make different. I mentioned as we are currently bootstrapping this using Kube Builder. We use cluster registry as the source of the cluster endpoints. So when we install the federated API or the federation control plane, it needs to know about what clusters to federate and what clusters to propagate the resources to. So we use cluster registry as the source of that information. I'll be dealing with a much more deeper view of the same thing. I'll be talking about the controllers, I'll be talking about the layout of the API, I'll be talking about the groups it involves and all that stuff. If you are interested in that, please attend the deep dive tomorrow. So this is I won't call it an architecture, it's more like a concepts diagram. It is available on our GitHub page also. So what it says is that conceptually you have a cluster configuration and you have a propagation configuration and you have type configuration. Type configuration means for the particular resource. So for a replica set or for a deployment or for a secret, that's to do with the type configuration. So these three things is received through the API, and the API surface, the building blocks comprises of the template, placement and overrides for a given K8s type. And using only that much, the upper half, the upper three boxes here and that configuration, any K8s resource could be federated. And the simple federation would be that a given resource can be propagated as is to the given clusters. For example, you want to put secrets, you have say 5 clusters, and you specify the list of those 5 clusters in your cluster configuration. And in your propagation configuration, you say that propagate only to first 3 clusters. And in the type configuration, you say I want to propagate Kubernetes secrets. Then template placement and overrides are sort of created for you or there for you. And if a user creates a federated secret in the federation control plane, the secrets would be created in the first 3 clusters based on the cluster configuration. There are, so I mentioned that it's more like a layered approach. Using that basic building blocks, much more complex things can be built. So a dynamic scheduling can be done. We in fact already have a dynamic deployment and replica set scheduler, which basically takes input as how many replicas do you want to distribute across, say, 5 clusters. You can say 50 replicas, and the scheduler will automatically partition that. It will watch the individual clusters for failing replicas, it will rebalance and all that kind of stuff, but using the building blocks. And we also have a cross-cluster service discovery. I'm talking about features which are already done, which we have already completed in our effort. And similar higher level stuff can be built using these lower level concepts. I did not talk about status. So status is something which is collected. So when you say rest of the APIs, it's always propagated. Status is something observed from individual clusters, and based on that observation, the schedulers, all the high level APIs can make their decisions. So what we have achieved so far, we have, like I mentioned, we started with aggregated API approach. We have been able to successfully move to a CRD based approach. And we have a API surface, which is a CRD installable on any K8s cluster. It has, there is a controller manager associated. We have a push reconciliation for any arbitrary type, like in fact, including the CRD. So if as a user, you have created your own CRD, and that is what you have in your clusters which you want to federate, that is also something which can be federated, and the push conciliation can be active on it or activated on it. We have completed the DNS based service discovery. We have completed the scheduling type that I mentioned. And we also have, so earlier what we used, what we needed to do was, like if I want to federate a given type, probably say stateful set was not federated earlier, and if I have to federate a stateful set, I needed to, generate some code, write some code, write some API stuff in federation control plane, and that after that compile and do a release, and that's how I would say that now federated stateful set is available. That need is not there anymore, so we are able to federate any arbitrary type without writing any code also. Yeah, and some scheduling behavior also is enabled. In the roadmap, we have overrides of arbitrary fields. So right now we need some code that is need to be written if you want to override some fields, meaningful fields. For example, replicas is a meaningful field which I might want to override when the replica sets are propagated into individual clusters. But support for any field was not there. We are building that support. The status I showed in one of the previous slides, the aggregation of that is not complete. So we are doing that. So aggregation of the statuses would be like user might want to know how a given resource is there in each of the clusters, what is the status of that resource in the clusters, and that in an aggregated way means, for example, replica set, current replicas, they all can be merged and total replicas can be shown, or the individual per cluster would be like current replicas per cluster can be shown. We are building more high level scheduling behaviors. For example, the job scheduling is, there's an open PR for that. We are also towards completion of the codeless federation. So, I mean, enabling federation of a resource without writing any code. So, we have already completed tooling for that, which we use kubefed2, and we say federate, and for example, I can say kubefed2 federate replica set if it's not already federated, or kubefed2 federate HPA if it's not already federated, and the CRD code for that would be auto generated and will be installed onto my API server. So far what we have been doing is push reconciliation. We might also be looking at the pull based reconciliation approach, which is more useful for Git based workflows and that kind of stuff. Okay, cluster registry, I can define cluster registry simply as a managed kube config. In very simple words, it could be called as a managed kube config of multiple clusters. So kube config is something which is local. Cluster registry, what it enables is it provides an API and an active controller using which users of that API can get the information about the clusters and the details of how to authenticate with those clusters and all. This was done say 6 months ago, and there has been some main problems which are around the authentication, because of which we have not been able to go towards beta for this. This also update is that it has been, cluster registry also is a CRD which is available as of now, and status field is updated. Our intention is to move to beta once the discussions about the authorization are resolved. Kubemci is a tool which can, currently is done only for Google, but the concept can be extended for other clouds also. So for Google clouds, Kubemci is a tool which can program the Google load balancer, getting the information about the ingresses stored in the different clusters. So, this is something, the concept is about sort of a load balancer which is common to multiple clusters. So using that single endpoint, users or the users of the application which is deployed can reach out to the applications installed in the different clusters. And it can do geographical load balancing and whatever benefits are available with the Google load balancers. This is as of now beta, and one reason this hasn't gone towards GA is sitting around the K8s Ingress also. K8s Ingress also is one API which is not GA as of now. So yeah, this is something that I explained. So Kubemci folks are actually soliciting feedback from the users, and there is an issue open for that in the repo. Yeah, so this intro is also about trying to get the feedback from you folks, trying to get the feedback from the community, and easing out the involvement of new developers. So these are a couple of links, you can make a note of that. I'll upload the presentation also, so you can get the information from there. This is also some information. I'll upload the presentation which can be taken from there. And I think we are almost running out of time, so I'll keep say 5 minutes for the questions if there are any. And there will be much more details about especially Federation V2 into tomorrow's deep dive. So we can talk more over there also. So questions?
Hi. I understand that the Federation clusters are more for replication purpose. Would be any kind of plan to support to actually manage multiple resources in one cluster instead of just replication? For example, I have multiple environments, for example, my QA environment, my production environment, I want to interface it with one cluster.
That is not something that we have really spent a lot of time thinking about. This may not answer your question, but I presume you're familiar with Helm. So Helm is a good way of, aggregating lots of different resource types that comprise an application and making sure that they get deployed as a whole in a cluster. I'm not a Helm expert, but I'm guessing that you can do that more than once fairly easily. But it's an interesting concept, and certainly, having a test implementation and a production installation in the same cluster is a general problem. I think it's largely solved with things like labels and templates. But if that is not something that you can do with vanilla Kubernetes easily today, then it's worth thinking about. I think it's pretty much a solved problem, though.
Yeah, I can extend the answer. So the main concept around having multiple environments in the same cluster is solved using namespaces, right? The whatever work group that we are involved with, it is about handling multiple clusters, and we also have enabled the similar namespace based federation so that same clusters can be assigned to different users. So say you have 3 clusters, you can have workloads which span say production workload in a different namespace in these 3 clusters, and in a different namespace dev workloads could be installed in the same clusters. So that's how we are trying to deal with this particular problem. So we call it namespace federation.
This wasn't your question, but I wanted to mention this anyway, so I'll just take this time very briefly to do so. Another area which we haven't spoken about yet is that these clusters don't need to run on the same cloud provider. So each cluster, you might have clusters running on Amazon AWS, on Google, on Azure, on-premise, etc. So one of the goals of this is to provide you with a consistent deployment experience, even if you're doing multi-cluster or multi-cloud provider deployments. And we haven't solved all the problems. Certainly things like inter-cluster networking become tricky, especially if you have different cloud providers and different networks. But that's very much within the scope of the stuff we're solving. And we have some work going on with the Istio folks, for example, to span multiple clusters using Istio meshes. And that'll go some way towards solving that class of problems. And there are other similar problems. How do you move storage around between different cloud providers that have different storage topologies?
Will the group plan to solve the problem that multi Kubernetes cluster with different Kubernetes version?
That's a very good question. It's too hard for me, so I'm going to give it to Irfan.
Yeah. So the Federation API, so this was one of the problems. So I'll repeat his question again. So what he's saying is, how do you solve the problem of federating APIs from different clusters, all of them with, say, different API versions? That's right? Yeah, different Kubernetes versions itself. So different Kubernetes versions might have different API versions. So that's how the problem is broken down. So earlier what we were doing is, in Federation V1, we were using the same API or replicating the same API. So we were actually, we were trying to break our head which version of the API to use if we are federating clusters which are of different versions. Now what we have done is, we are using Federation specific version. So our API has its own version, and at any given point of time, we use the, for a given cluster, we use the uppermost or the highermost available API version of that cluster. So that way we are able to federate, say, a range of different version Kubernetes clusters, and it doesn't break per se. But it does not guarantee that the break cannot happen, because a different API version, if a previous K8s version has an older API version, might not have a newer field which is available with a newer version. So that's so far in our tests and whatever we are doing, we are actually federating different versions also, and we have seen versions from 1.9 onwards, the latest release, and it all works fine, but it doesn't guarantee that the break would not be there.
I have 2 questions. Question number 1 is, when we want to do a hybrid cloud solution, because sometimes we deploy our workload in private cloud, and does this solution solve the issue that ought to migrate some workload when there's some high usage in private cloud to public cloud? And the second issue is, because right now we are considering deploying a huge cluster Kubernetes, but for one single Kubernetes cluster, when it reach 1,000 or 2,000, it is some kind of limit, unless you do some kind of refinement. But what if we use this kind of federation or multi-cluster to use it to solve this problem? And this question is, how many subcluster it can handle?
Okay, I can. So the first question, first question was something like, I actually had a talk about that in the previous KubeCon, and the title of that talk was Cloud Bursting with Kubernetes. So we did a feature called Federated HPA in Federation V1, and it actually solved this particular scenario. So if you have high usage in, say, on-prem cluster, it will move the replicas using the HPA concepts. It will move the replicas to a cloud cluster or a hosted cluster somewhere. The second question. Okay, so the second question is probably about scalability. To what scale can you go? So the scalability is limited by the storage and the computation that we have. So we are not putting any cap or the upper limit as of now, and we haven't done scalability tests honestly. So, but there is no upper cap on what we say the number of clusters that we can federate or join together. In due course of time, probably we'll be doing those scalability tests also. But the first step is that getting acceptance from the user community and getting feedback from them.
I can just add very briefly to that, and we're out of time now, so I'll be very short. But our initial thinking was, 100 clusters roughly was kind of a sensible number. We've subsequently found users who have many more than that, like 1,000 or more.
And it works.
and we haven't, there are no fundamental design things that are different. You can think of it as a similar scaling problem to Kubernetes. How many nodes can a Kubernetes cluster manage? And that, depending on how you set it up, could be thousands, and this is sort of bounded by similar constraints. In fact, less in a way. Conceptually, you could manage more clusters than Kubernetes can manage nodes and run into fewer problems.
We are actually using the same API plane, and a controller is an application in Kubernetes. So that's the scalability is limited by the K8s scalability itself. Any other questions? We are actually out of time officially.
But if you have more, please